Hello, I'm Panise Jasby, Chief Science Officer at Therium. Today, I'll walk you through how our Aristotle test quantifies mutational load, the real-time balance between genomic damage and repair, and how those data translate into actionable care for your patients. First, a quick roadmap. We'll review the concept of mutational load, then dive into each of the three subdomains that drive this score. Those are quantitatively oxidative stress, mutagenesis, and DNA repair. I'll finish with three case vignettes to show how the numbers guide therapy and end with a key take-home message. Mutational load is the cumulative DNA damage debt that a body carries. These can be point mutations, base lesions, even chromosomal rearrangements. Intrinsic ROS, or reactive oxygen species, as well as extrinsic agents such as UV or carcinogens, these push damage forward, and the DNA repair machinery pushes damage back. Our platform monitors this tug of war with targeted metabolomics across the three subdomains you see here. When damage outpaces repair, oncogenic risk and functional aging accelerate, often silently. Oxidative stress is our first pillar. We track CAMP or cyclic AMP as an early redox signal, L-tyrosine and its 3-nitroderivative as a threshold marker for the ratio between reactive oxygen species and reactive nitrogen species, which signal protein damage, and circulating sucrose as an indirect readout of glycooxidative load and gut permeability. Now, the box plots on the right, patients with Wilson's disease versus controls, illustrate how nitrotyrosine sensitivity registers heavy metal-induced oxidative injury. Clinically, a poor score flags higher risk for cancers, cardiometabolic diseases, and even cognitive decline. And intervention is straightforward. Tighten glycemic control, replete antioxidants, and remove lifestyle drivers of chronic ROS, which can be smoking, unmanaged stress, or sedentary behavior. Subdomain 2 is mutagenesis. Our sentinels are 3-methyladenine, which is a canonical alkylation lesion, and the pyrimidine pair uracil plus dihydrouracil. Now, the figure that I'll present shows tumor DNA from UNG SMUG1 double knockout mice, where unrepaired uracil drives really a tsunami of C to T transitions. And really, the takeaway is that these base lesions are not benign. They eventually become fixed mutations. Endogenously, cytosine deaminates and SAM overshoots its mark every minute. So this 3-MEA accumulation tells us that ER is overwhelmed and uracil signals cytosine loss. Dihydrouracil flags a clogged pyrimidine catabolic arm, often folate cycle drift. Then we layer on our 4,598 SNP panel across 72 repair genes, and we can distinguish a transient metabolic glitch from an inherited repair deficit, which is critical for precision risk stratification. So elevated mutagenesis scores correlate with higher cancer risk, developmental anomalies, and if germ cells are effective, then we have chronic inflammation from persistent DNA damage signaling. In this case, therapy would start with removing alkylator exposure. So these could be cigarettes or workplace solvents, while really ensuring that the one carbon nutrients like folate and B12 keep this BER humming. Elevated mutagenesis scores correlate with higher cancer risk, developmental anomalies if germ cells are affected, and chronic inflammation from persistent DNA damage signaling. Finally, we have DNA repair. So we monitor seven metabolites here that map to three repair axes. Adenine, adenosine, deoxyadenosine map to the DNA PK energy drain. Guanosine is for purine salvage and gap filling capacity. And we have thymine, uridine, and UDP-GLICNAC for excision output and O-GLICNAC dependent ligation. This figure from Nature Communications shows radio-resistant glioblastoma cells with elevating purines and UDP-GLICNAC, proof that the networks work in concert. When PARP and DNA PK sort of lighten up, NAD plus and ATP fall. So the adenosine adenine ratio tells us exactly when the tank is empty. UDP GLICNAC storage means that XRCC1 and P53 can't properly become glycosylated. So this leads to a sort of a sloppy ligation pattern. Now, the systems panel captures failure modes that a single gamma H2AX snapshot really cannot capture. Low repair scores for accelerated aging, as well as tumorigenesis, immune glitches, and even premature senescence. So we can intervene by boosting NAD plus precursors, balancing nucleotide intake, and leveraging sirtuin activators like resveratrol to extend enzyme longevity. Let's get into our first vignette. A 47-year-old accountant with fatigue, palpitations, and brain fog. Our Aristotle flagged elevated sucrose, erratic cyclic AMP, CAMP, and low tyrosine. Dietary sugar spikes, we postulated, were feeding ROS and disrupting CAMP signaling. And after 3 months on a low GI diet, moderate exercise, and antioxidant support, her metabolites normalized and symptoms lifted. This illustrates how biochemical insight will drive this targeted lifestyle therapy we recommend. In case 2, we have a 55-year-old smoker with a high 3-methyladenine, a skewed dihydrouracil to uracil ratio. This is textbook alkylation stress plus BER strain. What we asked her to do was intensive smoking cessation. We repleted her folate and B12 levels, and we added cruciferous vegetables to cut the 3-MEA markedly within 6 months. Again, underscoring how source control plus nutrient support reduces mutational burden. And our final case, a 60-year-old oncology nurse with fatigue and alopecia. We saw low adenine nucleotides and UDP GLICNAC pointed to a repair substrate depletion from chronic low-dose radiation, we suspected. We reduced exposure. We added nicotinamide riboside NR to replete her NAD plus pools. And we also increased her intake of purine-rich foods and taught mindfulness to dampen cortisol release. 4 months later, her repair panel improved and symptoms receded, proving that repair capacity is modifiable. To close out, mutational load marries damage and repair into one actionable index. Targeted metabolomics, like the panel of the Aristotle, lets us pinpoint biochemical choke points, and early domain-specific interventions can curb cancer risk and slow biological aging. Thank you so much for your time.